Hi, my name is Emily Denis, and I'm on the product team at Simon Data. Today, I'm going to walk you through how to validate your customer identity model using our Snowflake-native app, IdentityQA. Before we get started, I wanted to highlight a couple of things. To follow along, you need to install Simon Data's IdentityQA native app from the Snowflake Marketplace. This application also assumes that you have a basic understanding of your company's identity model, meaning you know which identifiers you use to build customer profiles and how those identifiers relate to each other. For example, is email one-to-one with phone number? I'll be walking you through how to configure an input table, run the IdentityQA application, and interpret the report at the end in order to strengthen and improve the accuracy of your identity model, which in turn strengthens and improves the accuracy of your marketing team's efforts. In this video, you'll learn how to install and use a Snowflake native app, whether or not the assumptions you've made about your identity model are true, which email addresses and phone numbers are invalid and could be cleaned up, and how to generally improve your identity model based on the native app's findings. It's important to note that Snowflake native apps provide many benefits from a security and privacy perspective. The native app frameworks allows for providers like Simon Data to create an application package that includes metadata, setup scripts, and business logics. Providers then publish the application package as a listing on the Snowflake native app marketplace, where consumers like you can install the application package and create the application in your own Snowflake instance. Simon Data, as the application provider, does not have access to the underlying data you run through the app, nor does it make any changes or transformations to that data. You control the application's access to database objects, and the output of the application is a set of tables in the application schema that you can query to see the results of the QA on your identity model. For the purposes of this video, I'm going to assume that you have the IdentityQA application installed already. If you need help installing the app, feel free to take a closer look at the quick start linked below. Once installed, in a worksheet, you'll be able to expand the app schema and see a set of procedures. I'll walk you through how to use these in a bit. Before the app can run, you need to give it access to the database, schema, and table you want to use. Run these commands on my screen to do so. Grant usage on database, grant usage on schema, and grant select on table, where your database name is the name that contains your input table or view and will contain the IdentityQA output. Your schema name is the database schema from the last argument that contains your input table or view and will contain the IdentityQA output. And your table name is the table name that will serve as the input for the IdentityQA application. Once you've granted sufficient privileges to the application to access the data, you can set your input table. In your worksheet, run the set input table stored procedure that you see here. Be sure to include as many lines as you have identifiers in your source table. And don't forget to rename the application in this command to whatever you named it when you installed the app. So in this template here, you can see call chosen app name. This is where you would replace this with the name of the app in your Snowflake instance. Set input table, source table, where source table is the table name you specified when setting up and granting usage to the app in the above commands. This should be fully qualified, meaning it should be formatted like your database name dot your schema name dot your table name. Source column is the column name that contains the identifier you're configuring. Identifier type defines the type of identifier in the previous argument. And we support many identifiers such as email, user ID, phone number, custom ID, whatever you have in your input table. But one quick thing to note here is that in order for some of the identifier validations to run properly later on in the application, if you're including email and or phone number, they must be named in a particular format, and I'll show you in my example. IsStable is a Boolean field that tells us whether or not the identifier should be stable. A stable identifier is one that is unique, is one-to-one with a single profile, and cannot be shared across profiles. If the identifier you're configuring is stable, put true here. If it is not stable, put false. Another quick note here, by definition, because a stable identifier is one-to-one with a profile and cannot be shared across profiles, you can only have one stable identifier in your input table. So in my example here, I'm calling the Simon IdQA app. I'm setting my input table where the source table is simondatatest.public.identity. My stable identifier is email because it says true here, and it's named email. In order for the email validations to work later on, it must be formatted like this, just email. My client ID is my custom ID. It is not stable, so I put false. And I'm also including phone number. And like I said earlier, phone number is a special identifier that must be written in this format in order for it to work in the data validations down the line. Phone number is also not stable, so I put false here. So I'm going to go ahead and run this. We'll see it run, and we should see a success notification that our input table is set. Once you've configured the identifiers in your input table, you can set certain constraints or assumptions to validate. These constraints outline the relationships between two identifiers. For example, if there is a one-to-one or one-to-many relationship between two identifiers, and identifier-specific limits. For example, device ID can be shared across a maximum of 5 profiles. The first constraint that we're going to set is the relationship constraint. Set relationship constraint command like so. Let's test whether or not client ID is one-to-one with email address. We'll input one-to-one as the relationship type and client ID and email as our identifiers. So remember, again, to rename the app. So whatever your chosen app name is, you would input it here. So in this case, I've input IdentityQA. We're setting the relationship constraint. We're testing one-to-one between client ID and email. The reason I have 2 lines here is important. One thing to note with the one-to-one relationship is that if you want to validate that it's one-to-one both ways, you have to set 2 relationship constraints. If you only check the one-to-one relationship going one way, you may get a false positive in your report at the end. So be sure to include the inverse in your command as well. So I will go ahead and run the relationship constraints right here. Success. All right, the next constraint checks for the uniqueness of the values for a particular identifier. Call IdentityQA, set unique constraint, insert identifier name here. Let's check the uniqueness of client ID. Success. Our last constraint that we're going to set is called a shared identifier limit. In this template, we've got the chosen app name, the set shared identifier limit stored procedure, the identifier name, and then the threshold. This last constraint sets a maximum threshold for which a single identifier can be shared across different profiles. Let's say that one of your customers has a landline that they share with everyone in the household. The average number of people in a household is 3, and you believe that your customer base tends to have landlines. You could set your shared identifier limit threshold to 3 for phone number to validate this assumption. So let's do that here. Call IdentityQA, set shared identifier limit for phone number 3. Success. Now for the most exciting part. You set your input table, you configured your identifiers, and you set all of the constraints you want to test. It's time to run the report and get your results. Run the report stored procedure like so to generate your IdentityQA report. This may take a while depending on how many records you're running through the app. There are 2 ways for you to check out your results, and I'll walk you through how to do both. First, we'll manually inspect the report. Your report will be available in several tables in the report schema within the IdentityQA application. To query the tables directly in the report schema, you can run a set of commands, which will be available in the Streamlit for easy copy pasting. Once this report is finished executing, I will be able to show you. But here in the report schema, you can see all of the tables and all of the reports. Success. First, you can run this query to pull the table names specific to your identifiers. Port.cardinality check email client ID, cardinality check email phone number. Now, you can run a select star on each of the tables that were generated. So for example, we will replace check user ID email with email client ID. And the same thing for email phone number. So let's check this cardinality report. You can see here that we've got some email addresses that have a very high count of client IDs associated with them. I will walk through what these results mean when we go through the Streamlit. For the sake of time, I'll check just a couple of others. So let's check invalid identifiers. You can see here that we have a couple of invalid identifiers. For example, this first one here is test+29@nxdomain.com. The reason this is invalid is because there's no @ symbol. You can't reach them. Let's check one more report here. Let's do the relationship constraints check. So you can see, if you remember, we set one-to-one relationships for client ID and email, and we did it both ways to ensure that we're testing one-to-one both ways. So you can see that client ID to email is one-to-one, it passed the test, but email to client ID failed the test. I'll walk through these results in a little bit more detail when we go through the Streamlit component. To view your report in Streamlit, return to the app and launch it in Streamlit. If you're in a worksheet like we are now, click this back arrow to return to the main Snowflake page. Click Apps in the left-hand nav, but make sure you're in the correct Snowflake role first. Click the IdentityQA application to launch the Streamlit. The name of the app on this page should be what you named it upon installation, so it may be different from what I'm showing you here. Once you've opened the Streamlit, select a warehouse in the upper right-hand corner, if one is not chosen already. Your Streamlit will now load. Like it took a while to generate the report, depending on how many rows you have through the app, your Streamlit may take a while to load as well. There are a few pages in the Streamlit here that you should explore if you're interested, but for now, I'm just going to walk you through how to interpret the report you generated. So I'm going to click on the report page. All right, before we dive into the report, I'm going to quickly show you the input table. As you can see here, we have email as the stable identifier with client ID and phone number as additional non-stable identifiers. The top of the Streamlit report shows you the name of the input table you configured, as well as the total number of rows in said input table. In this case, we've got 1,072. Constraint checks. Next, the report shows us pass-fail statuses on the constraints we configured. As you can see here, the client ID and email identifiers passed the one-to-one relationship check, going one way but not the other, and we saw this when we manually inspected the reports in the worksheet. This tells you that for every client ID, there is only one email, but the app found instances where a single email had more than one client ID. We'll explain examples of these failures later. Additionally, the shared identifier limit check failed on phone number. This means that the app discovered instances where a single phone number appears on more than 3 profiles, which violates the assumption that phone number is shared at most across 3 profiles at any given time. Here we can see that client ID did indeed pass the uniqueness test. The next check is a high cardinality test for each identifier in the input table compared to the stable identifier. We test for cardinality because exceptionally high counts of any identifier per single stable identifier, like these, generally mean that there is an issue with the underlying data. If you think about the number of email addresses you have in real life, or the number of phone numbers you have, you'll realize that you and probably most people likely have fewer than 5 emails or phone numbers. In this report, you can see that there are 10 profiles that have an exorbitantly high count of client IDs per stable identifier. This tells us that these emails may be fake, or maybe they're emails used for testing purposes or integration testing, and they should be excluded from marketing. Your next step here should be to dive into these email addresses in your database and determine why they might have so many client IDs associated with them, and if they're valid profiles or not. If they're invalid, we recommend cleaning them up. Why spend marketing dollars sending messages to a profile that's used for integration testing, or a fake profile? Next, our report shows email and phone number validations. You can see here in this table that out of the about 1 million total records in the input table, about 30,000 of them are considered invalid, while 80,000 phone numbers are considered invalid. The tables below provide specific examples of questionable emails and phone numbers so that you can easily inspect them further and clean them up or remove them from your database entirely. I want to pause here though and note that invalid in this case means that the email or phone number is missing one or more properties in order to be considered a real contactable identifier. Emails with no @ symbol are flagged here, as well as phone numbers with letters in them or fewer or greater than 10 numbers. We are not testing whether or not these emails or phone numbers belong to real people instead of bots. You can see here that these email addresses have no @ symbol, and these phone numbers are likely invalid because of all of the zeros. All right, congratulations. You have successfully QA'd your customer identity model using Simon Data's native Snowflake app, IdentityQA. You should now have the insight you need to be able to fine-tune and improve your identity model. To recap what you learned whether or not the assumptions you've made about your company's identity model are true, the percentage of invalid email addresses and phone numbers in your identity table with specific examples for easy cleanup, and how to improve your identity model based on our native app's findings. If you loved this video, continue exploring this Quick Start Lab, make changes to your identity model or input table, and run the application again to see how it improved. Linked below this video are some helpful resources for you. Thanks so much for listening and happy validating. See you next time.